All right, so let's go through the notes for day one of conics. So a conic section are the different cross sections created by cutting a double-naped cone, which I know is a funny word, with a plane. Double-naped cone is made when two solid cones are connected at their vertices. So you can see here one cone, two cones. The point where the vertices touch is called the origin. We're going to look at the different cross sections that you can get from a double-naped cone, just like you did in the demos. So what we've got here are four different possible shapes. One is called a circle, and this is the easiest one. And the way you get a circle is if you took a plane, and here's where my artistic abilities are somewhat limited, and you were to cut it straight on. That's where it would cut through the cone. Pretend that was straight. And it would form a circle that's parallel to the tops and bottoms of the cone. And so the cross section will look more like an actual circle. Whee! The next shape we can get is called an ellipse. Not an eclipse, an ellipse. And I always think I'm going to spell ellipse wrong. Nope, there are two L's. An ellipse. And the way you get an ellipse is you just take this plane that we cut the cones with and you rotate it a little bit. So here's my plane coming through. And the cross section that you get will look more like that. And so the shape of it will look more like this. It'll either be longer than it's wide or wider than it's long, one way or the other. The next one we tend to get is called a hyperbola. And you get that shape if the piece of paper is cutting through the cones and hits both cones. That's a little hard to draw, but imagine that you've got something like this going on, something like this going on, and it's hitting both of them. And you'll end up with a shape that looks something like this in the cross sections. And it looks a heck of a lot better in the interactive demo you should have seen in the previous video. So in general, you get shapes that kind of look like this and like this. Or they could be rotated too. The last kind is a parabola, which you studied a lot in algebra and algebra 2, but we're going to look at them from the perspective of conics now. And the way you get this is if you have your sheet of paper that's cutting through the cone is parallel to the what do you call this? The diagonal. That'll give you the parabolic shape. So here you're going to get a parabola. So if that's not 100% clear, if you go back and look at the interactive demos with the video, I think it's a little bit clearer. Okay, so here's the really important stuff we're going to do today. We're going to talk about circles, which are not that big of a deal. But it's important to know. So you need to find in this form of the distance between 2 points on the graphs below. And we're supposed to leave our answers in simplified radical form if appropriate. So if you look here, we want to know that distance. So if you were to count over 1, 2, 3, 4, up 1, 2, 3, you'll notice that we have a right triangle, and we could do the Pythagorean Theorem. 3 squared plus 4 squared would be our distance squared. That's 9 plus 16 equals d squared, which will equal 25. And if you square both sides, you get that d is 5. Likewise, for the next one, you could count. Counting starts to get a little bit tricky here because we have negatives. So I'm going to show you a way that we could find the distance between the x's and y's. Essentially, if you do 7 minus negative 3, that's how far apart the x's are. So that would be 10. And then if you do negative 1 minus 5, that'll give you negative 6. You should think about those numbers and make sure they make sense. That from -3 to 7 is a distance of 10, and from 5 down to -1 is a distance of -6 in the negative direction. Now that we know these distances, we could do the Pythagorean theorem again, because we know that this is -6, that is 10, and so we do -6 squared plus 10 squared equals d squared. I'll just tell you that's 136. So you end up with the square root of 136 equals d. Now the directions do say leave it in simplified radical form, so we do need to simplify this. And so for those of you who forgot what that means we need to find if there's any perfect squares that are factors of 136. So what I'm going to do, I have my calculator off screen, unfortunately. I'm going to start going through and dividing 136 by different numbers. So like I'm going to take 136 and divide it by the first perfect square is 4, and I get that to be 34. And so what that tells me I could do is I could rewrite this as the square root of 4 times the square root of 34, because 4 times 34 is 136. The square root of 4 is 2, so 2 root 34 would be distance. All right, so now we're going to do a little bit of an investigation here. So we want to find the distance from 0, 0 to xy, and we know that it's 5. The question is, could we find out what x and y is? We're going to find 12 points that work. So we're starting here, 0, 0. And it's easy to find some points that are 5 away from here. Like if you go up 1, 2, 3, 4, 5, let me switch colors. That point's clearly 5 away. That point's clearly 5 away. Here's a point that's 5 away. And here's another point that's 5 away. Now that's probably not all of them, because my guess is, and I think you can understand this, if you were to go on an angle, you could find more points that were exactly 5 away. So for example, if you were right about, I'll rotate this point over, maybe right there, that point's probably about 5 away as well. And maybe somewhere around there too. And probably without too much guesswork, you're starting to figure out that this is going to be defining what we'd call a circle. If you go around, whee, all the points that are on this shape, yeah, this is no, it's not too bad. I've drawn much worse circles. I would not win the circle drawing contest for sure. All the points that are on this shape will be 5 units away from 0, 0. So like this point here, if you found the distance to this point, it has to be the same as the distance of this top point to the origin. So how many points are there that are 5 units away from the origin? The answer is there's an infinite number. Every point that's on that circle are 5 units away. 5 would represent the radius of the circle. The origin would represent the center of the circle. Now, here's where we get into something pretty interesting. So I'm going to label a point on here, just any generic point, and I'm going to call it the point x comma y, and this is the point 0, 0. To find the distance between the point x, y, and 0, 0, what we've done in the past is we've made, switch colors again, black. We've made this right triangle. So now what we'd have to know is how far are these different segments in this right triangle? Well, the first distance here is really just the x distance. The second distance is just the y distance, because that's how far away 0 is from y. And so if we want to get what this distance is, the radius, which we know is 5, we could do the Pythagorean theorem. So we would have x squared plus y squared equals 5 squared. Or, as we usually write it, x squared plus y squared equals 25. And that would be the equation of our circle. Now, what gets interesting is what happens if we were to not use 0, 0. What if we were to use hk instead? So we'll do this kind of from two different perspectives. So first, just say this is our point H, K, and this is our point X, Y. And we're going to assume that distance is still 5 for the purpose of our example. Let's switch colors. And there's our circle. So once again, we want to figure out how long those two lengths are in our right triangle to figure out the relationship with the hypotenuse. So the key is the strategy I showed you a little bit earlier, which is to figure out how long this x distance is. What we would use is the difference between x and h. If you subtract them, that's how long that side is. Likewise, this side length would be y minus k. So now if you look at what we have here, our equation would just be the bottom leg, x minus h squared, plus the right leg, y minus k squared. Oh, I have those so switched. No, I don't. Whew, I thought I had it backwards. Being sick, very confused. Equals 5 squared. So now we're going to write down kind of a summary of what we've just discovered. So a circle is a set of points that are equidistant from a center. Hopefully that makes sense. So a circle is the set of all points that are equidistant from a center point. The equation of a circle in standard form is going to be in this form, which is x minus h squared plus y minus k squared equals r squared, where h comma k is the center and r is the radius. All right, so that's the notes for today on circles. Hopefully I will be back the next day to go over this more with you all, but that it didn't seem too demanding.